Hi everybody, we have a question. We are expected to find all real values of x, for which we got this equation: x to the power of 4 positive x cubed negative 2x squared negative 3x negative 3 is equal to 0. So foremost, what I wish to do is, this is a quartic equation. I would like to write this quartic equation as a product of two quadratic equations. So let's do that. So x to the power of 4 positive x to the power of 3 negative 2 times x squared negative 3x negative 3 is written as a product of two quadratic terms. So that's going to be x squared positive ax positive b, x squared positive cx positive d. Now there are a few things you need to observe. You might be wondering why I have not taken any coefficient before x squared. For the simple fact that when we multiply x squared with x squared, we are expected to get x to the power of 4. That is a requirement on the left side. So that's the reason that I have taken the coefficient of x squared here to be as 1 and the coefficient of x squared here to be as 1. Also, the values that a, b, c and d can take should be element of z. So this is an important requirement that we need to have for solving this system. In other words, for writing the quartic equation as a product of two quadratic equations. So having said that, I would like to distribute the quantities on the right hand side. So that would mean x squared multiplied with x squared, that's going to be x to the power of 4, followed by x squared times c times x, that's going to be c times x cubed, followed by x squared into d, that's going to be d times x squared, then a times x squared, that's going to be ax cubed, followed by ax times cx, that's going to be ac times x squared, and then ax times d, that's going to be ad times x, then b times x squared, followed by bc times x, followed by bd. So now what I wish to do is, I would like to club the quantities of x cubed, x squared, constant term, and then write the terms in this following fashion. So after x to the power of 4, I get x cubed. In x cubed, I have an x cubed here, c, and is there any other x cubed, and I've got another x cubed here. So let me write it as a positive c, followed by x squared. In x squared, I have got ac term, I've got a b term, and then I've got a d term. So let me write it as b positive d positive ac. That's fine. And after x squared term, I've got x term. Let me write the x term also. I've got ad, that's one x term, and then bc is another x term. So ad is one x term and bc is another x term, and then the constant term. Where are the constants? Are there any constants? Okay, I got b and d as constants, so let me just place them here. So this is the distribution of the quantity that we have on the right hand side. Now let me equate it with the quantity on the left hand side, right? X to the power of 4, x to the power of 4, there is nothing to equate there. X to the power of 3 has a coefficient 1, so you can say a positive c is equal to 1. In x squared, you have b positive d positive ac is equal to negative 2. Place that, and then x term ad positive bc, x term is negative 3, and constant term bd is equal to negative 3. So this is what we have got. Now the objective is to extract the values of a, b, c, d. Once we extract the values of a, b, c, d, we will be able to substitute them over here and then solve and then find the values of x. So that is the main objective. Now clearly, if I were to take this as equation 1, equation 2, equation 3 and equation 4, now from 1, what is the requirement? A positive c is equal to 1. So when is it possible? Of course, this is possible for this condition. Okay, a is equal to 0 and c is equal to 1. If I were to take a is equal to 0 and c is equal to 1, I can clearly outrightly get left hand side is equal to right hand side. Now having set a is equal to 0, if I were to substitute for 2, a is equal to 0, so what do I get? I get b positive d is equal to negative 2. This is what I am getting. Now if a is equal to 0, you see here, this is going to go off and c is equal to 1. So this would give me b is equal to negative 3. Now if b is equal to negative 3, then this is going to be negative 3 positive d is equal to negative 2, d is equal to positive 3 negative 2. So that would mean my value for d is obtained. D is equal to 1 here. So I've got A, I've got B, I've got C, and I've got D. So that completes our requirement. Now if I were to take these values and substitute it here, say let me take this as A dash. Okay, therefore from A dash, what do you got? You got x squared positive ax positive b, right? This is what we have got. So now what I wish to do is I would like to take this versus this to be equal to 0. Now you might be asking, how is it I'm taking it equal to 0? Because this entire quantity is actually equal to this particular quartic, and this quartic is actually equated to 0. And that is the reason I'm taking it to be equated to 0. So if I were to substitute the values of a, b, c, d, what would happen here? This is going to be x squared. A is 0, but the value of b is negative 3. That's fine. X squared, and c is 1, so it's going to be x there. And the value of d is 1 here, so this is equal to 0. So now from here, x squared negative 3 is equal to 0, and x squared positive x positive 1 is equal to 0. Now if you were to check for the discriminant b squared negative 4ac, you can clearly see this is equal to 1 raised to the power of 2, negative 4 times a times c is 1, which is going to give us negative 4 less than 0. So therefore the roots are complex, and we don't want any complex roots, so we need to drop this, right? Now in this case, x squared negative 3 is equal to 0. I can rewrite it as x negative root of 3 times x positive root of 3 is equal to 0. From here, x negative root 3 is equal to 0 and x positive root 3 is equal to 0, which means x is equal to positive root 3 and x is equal to negative root 3. So therefore the roots are negative root 3 and positive root 3. Now this answer is valid only if we are able to substitute these results and establish the check. So let me perform the check here. So we are given this x to the power of 4 positive x cube negative 2 times x squared negative 3x negative 3 is equal to 0. So what I wish to do is put x is equal to root 3. So let me take this as some ab prime. Okay, so put x is equal to root of 3 in ab prime. So what happens? We need to produce the right hand side, which is 0. So let me substitute the value first. So this is root of 3 raised to the power of 4 positive root of 3 raised to the power of 3 negative 2 times root of 3 raised to the power of 2 negative 3 times root of 3 negative 3. This is going to give me 9. This is going to give me 3 times root of 3. This is going to give me 3 times 2 negative 6. This is going to give me negative 3 times root 3. This is going to give me negative 3. Positive 3 times root 3, negative root 3 times root 3, they get cancelled. So now all that I have is 9, negative 6, negative 3 gives me negative 9. So 9 negative 9 is 0, which is equal to right hand side. So x is equal to root 3 is a root for the given system. So now what we need to do is put x is equal to negative root 3. This is also one of the values we have obtained, right? So in AB prime. So what happens? So that would mean AB prime would now be rewritten as negative root of 3 raised to the power of 4 positive negative root of 3 raised to the power of 3 negative 2 times negative root of 3 raised to the power of 2 negative 3 times negative root 3 negative 3. This should be equal to 0. So let's see if it is equal to 0. This is going to be 9. This is going to be negative 3 times root of 3 negative root 3 raised to the power of 2. This is going to give me a positive value. So 3 times 2 is going to give me negative 6, and negative positive 3 times root of 3 and a negative 3. Positive 3 times root 3 negative 3 times root 3 gets cancelled, giving me 9 negative 6 negative 3, which is nothing but 9 negative 6 negative 3 is going to give me negative 9. 9 negative 9 is equal to 0, which is equal to right hand side. So clearly the solution set is negative root of 3 and positive root of 3, and that is a good place for us to stop. Thank you everybody. Enjoy your night.